We have with us Stephen, who is a Senior Engineer Product Certification with experience across the compliance industry, working in both tests, engineering, and certification. He is a technical certifier for various product approval schemes, including R&TTE, FCC, ISED Canada, Japan Radio, and MCS. His specialist experience includes ISO 17025 Laboratory EMC Radio Test Engineering and Regulatory Compliance Solutions. And with that, I will now hand the presentation over to Stephen, who will kick off with an introduction. Stephen, please.
Hello, and thank you for joining this presentation. This presentation will cover many aspects of risk-based compliance. The main topics that we will explore are a brief introduction to the RED, product identification, risk analysis, risk assessment, and strategy. The RED introduction will briefly cover the relevant concepts relating to risk assessment. In the product identification section, we will explore what should be known about the product, its functions and accessories in preparation for a risk assessment. In the Analyze Risks section, we will explore risk analysis principles, which include hazard and risk identification. In the Assess Risks section, we will explore risk assessment principles, including risk reduction and other potentially necessary forms of compliance. In the Strategy section, we will explore strategic considerations and documentation format. RED Introduction. In this section, I will briefly introduce the Radio Equipment Directive. It will consider those who are new to European radio approvals and those who are updating from the R&TTE Directive to the Radio Equipment Directive. After this section, you'll know what the Radio Equipment Directive is, its scope, any similarities and differences with the R&TTE Directive, and why a risk assessment is required. The R&TTE Directive has been repealed, and the Radio Equipment Directive allowed a one-year transition period, which has since expired. Since the 30th of June 2017, all radio equipment must comply with the RED to continue to be placed on the market. The RED is a legislative instrument for radio equipment approval within the EU. Legal marketing of the radio equipment in the EU is made possible through this legislation. The RED is based on a common approach legislative framework, which is recognized by CE product marking. The R&TTE Directive scope additionally included terminal equipment, whereas the Radio Equipment Directive only covers radio equipment. The Radio Equipment Directive includes all radio equipment which intentionally emit and/or receive radio waves below 3,000 GHz. In comparison with the R&TTE Directive, this means that sound and television broadcast receivers, radio determination equipment, and radio equipment operating below 9 kHz are all under the scope of the Radio Equipment Directive. To define radio equipment, this means an electrical or electronic product which intentionally emits and/or receives radio waves for the purpose of radio communication and/or determination, or an electrical or electronic product which must be completed with an accessory, such as an antenna, so as to intentionally emit and/or receive radio waves for the purpose of radio communication or radio determination. As with the R&TTE Directive, technical compliance with the RED is established with a set of essential requirements. The essential requirements are concerned with health and safety, harmful interference, or EMC, effective spectrum use, as well as other less common additional requirements for particular products. Article 3.1a, Health and Safety, is intended to ensure the health and safety of persons, domestic animals, and the protection of property, including objectives with respect to safety requirements as set out in the Low Voltage Directive, but with no voltage limit applying. Article 3.1b, Electromagnetic Compatibility, is intended to ensure an adequate level of electromagnetic compatibility as set out in the EMC Directive. Article 3.2 is intended to ensure effective use and support for efficient use of the radio spectrum in order to avoid harmful interference. Article 3.3 covers additional requirements where decided by the European Commission when invoked by a delegated act. Where available, harmonised standards still provide a presumption of conformity. A presumption of conformity means that one can presume compliance is reliably ascertained through the application of a standard that provides the presumption of compliance with the essential requirements. It is important to note that this is made possible because the European Commission pre-approved such standards in an official journal. One of the most critical requirements under the Radio Equipment Directive is the need for risk assessment. Combined equipment is radio equipment. The definition of radio equipment does not allow treating inbuilt radio functionality separately from the main equipment. The presence of an inbuilt radio module makes the whole product radio equipment. This means that if, for example, an off-the-shelf radio module is integrated in a non-radio product, then the overall final product effectively becomes radio equipment and is subject to the RED. It is still important to note that for some products falling under the scope of the RED, the product may still fall under the scope of other native product directives, such as medical equipment or toy directives, for example. And so in these cases, the requirements of multiple directives may need to be satisfied. TTE Guide EG 203367 provides guidance for multi-radio and combined radio equipment. Where products integrate radio modules, the radio function is often considered to be a secondary function to the overall product. This is an important consideration for products that may fall in the scope of other product directives, because harmonised standards under the RED may not necessarily cover all functions of combined equipment, including non-radio functions. And harmonised standards under other directives may not necessarily cover compliance for the radio functionality. This means that combined equipment may require notified body certification in order to establish conformity with the directive. Complying with the RED requires a conformity assessment. Assessing conformity considers how a product meets all applicable requirements of a directive, not just the essential requirements, which primarily affects the test requirements. Conformity assessment is conceptually an act of certification, and there are three types under the RED. These procedures are outlined in Article 17 of the RED. Annex 2, Annex 3, and Annex 4. Annex 2, Internal Production Control. There is no notified body involvement for this route. This is commonly called self-declaration and is a form of self-certification. Annex 3, EU type examination and conformity based on internal production control. A notified body is involved to assess the technical documentation and provide a third-party certification of a product. Annex 4, full quality assurance. A notified body is involved to assess design, manufacturing, inspection, and test processes. Annex 2 and 3 are the most common routes. It's important to remember that self-declaration is possible where applicable standards are harmonised in the official journal. That is the result of test standards being agreed between industry and the European Commission. Where harmonised standards are not available, then a notified body is required to be involved in order to qualify a product's conformity. This ensures an independent third party evaluates compliance where no harmonised testing is available. There are two main guides for interpreting and applying the Radio Equipment Directive, the Blue Guide and the Red Guide. The Blue Guide is the implementation of EU product rules. This provides official interpretation and application of the legislation. This is cited in the official journal and therefore is an official guide of legal standing. The majority of questions about placing a radio product on the market can be answered by referring to this guide. The Red Guide intends to provide additional information that is not specifically provided in the Blue Guide. This guide is not official and has no legal standing. In the event of any differences between the provisions of the Directive and the Red Guide, the provisions of the Radio Equipment Directive prevail in all cases. In all cases, the RED requires a risk assessment in the technical documentation. A key point is that the RED requires an analysis and assessment of risks. In other words, a risk assessment is required. Throughout the RED, the theme of risk relates to the essential requirements. For most products under the RED, essential requirements of health and safety, EMC and spectrum use always apply. And therefore, the intention is to ensure compliant levels of risk with the essential requirements. Where a product can be self-declared as conforming to the RED under the Annex 2 route, a risk assessment is still required. Annex 2 of the RED does not explicitly specify the provision of a risk assessment, and so this has caused some confusion for those already applying the RED. The RED is a recast of the R&TTE Directive based on new common framework. Within Annex 2 of the common framework, the provision of a risk assessment is much clearer, and so a risk assessment is implicitly required under the RED Annex 2 self-declaration route, even though it does not necessarily include the same text as the common framework. In addition to this, the RED Annex 3 EU type examination procedures are in effect a notified body conformity assessment of the Annex 2 production control. And because a risk assessment is expected by an Annex 3 assessment, the provision of a risk assessment under the Annex 2 self-declaration route, or internal production control, is also implied. So what are the risks? All radio equipment present risks that they may negatively affect the health and safety of users, cause harmful interference to other products or the radio spectrum. The purpose and process for assessing risks is not necessarily a new concept. Risk-based approach to compliance was also within the General Product Safety Directive, and so the concept of ensuring risks to compliance are minimised has existed for many years. The Radio Equipment Directive extends risk-based compliance for all essential requirements, and so the risk assessment does not only apply to health and safety, but also applies to EMC and spectrum use, for example. The overall intention is to reduce risks so that they are low. Therefore, a risk assessment is a fundamental process for establishing compliance. It's important to note that simply demonstrating compliance through testing is a way of reducing risks. However, this is not a risk assessment in itself, and so applying test standards alone is not enough, as this does not constitute an actual assessment of the risks. A risk-based compliance assessment identifies product functionality, analyzes and assesses risks to compliance, and implements risk reduction measures for demonstrating compliance with the essential requirements. We'll explore the key stages of this approach in the following sections. Summarising what we have explored, the RED provides the legal framework for marketing radio products in the EU. Includes all radio equipment which intentionally emits and/or receive radio waves below 3,000 GHz, and establishes compliance with a set of essential requirements covering health and safety, EMC, and spectrum use, and where applicable, additional requirements. A risk assessment provides the technical basis for compliance with the essential requirements and is required for self-declaration and notified body assessment routes. Product identification. After this section, you will understand what product information is required, how accessories may affect compliance, and what considerations to make regarding intended and foreseeable uses. The first key stage for a product risk assessment is identification. Product identification aims to clarify the product functionality, how it is used, and what is used for. This may also include explanations of use with accessories or other parts. Product accessories. What is the product? What are the radio functions? What are the non-radio functions? What accessories are provided or used with the product? What components are critical for compliance? Risk assessment targets product functionality and uses. With this in mind, we need to understand what the product is and consider the features of the product. Once this is fully understood, then the risks presented by the features of a product can be assessed. Products generally comprise of radio and non-radio functions. Examples of radio technologies could be short-range devices, wireless local area networks, cellular, RFID, or wireless power transfer. It's important to understand what the supported radios are, how they operate, and in which frequency bands they operate within. Examples of non-radio functions could be power supply, either by mains of battery charging, USB, or other data bus, or even features like personal media player, where an audio port or loudspeaker may be incorporated into the product. Accessories are important as they often affect the physical configuration of the product or provide non-radio functions, such as battery charging or USB connectivity, for example. Critical components for compliance should also be identified, and although this typically relates to product safety, a detachable antenna, for example, is critical both for RF exposure and radio compliance, and so any changes to the antenna part may affect all essential requirements. Product uses. What is the intended purpose and uses of the product? Who and what equipment may use this product? Are there any foreseen or intended conditions that need to be foreseen? Products uses should primarily consider what the intended uses are. However, reasonably foreseeable uses or conditions must always be explored in relation to health and safety. What is the purpose of the product? What does it do and how does it do it? For example, a smartphone might be intended for general public and will allow the user to make phone calls using GSM technology, access the internet using Wi-Fi, and take photos with an inbuilt camera. It is intended for a domestic environment, but users may foreseeably take the phone into aquatic environments, such as a swimming pool. It is provided with a compatible USB cable for battery charging and file transfers to a PC. And the Wi-Fi can be configured into a hotspot mode, and so it's foreseeable that the general public may be inadvertently become exposed to radio waves. Being clear about the intended use of radio equipment is critical because unless the configurations and functions or uses of a product are fully understood, it would not be possible to demonstrate compliance for all of these aspects of the product. Accessories are also important as they can influence compliance and so must be considered an intended item for the use with the product when provided with the product. Where accessories are not provided with a product, it could be foreseen that such an accessory may be used in conjunction with the overall product, and therefore a diligent approach would be to ensure compliance based on a representative accessory configuration. The RED requires foreseen uses to be considered for Article 3.1a, Health and Safety, and so all other essential requirements need only to consider intended use. What is foreseeable use and what is considered reasonable or predictable? What do you know about the product, its intended uses or environment that may lead to unintentional but predictable use? For example, is it possible that a smartphone may be dropped into a pool of water accidentally? If a smartphone was submerged underwater, how would this affect battery safety afterwards, for example? An outcome of this might be to ensure ingress protection sufficient enough to reduce the risk by safeguarding a potentially dangerous fault condition during or after the device is unintentionally submerged in water. Foreseen misuse is slightly different in its meaning, but is an important concept because it implies that the product is used incorrectly and may foreseeably result in non-compliant operation. However, the RED states that the reasonably foreseen use is when such use could result from lawful and readily predictable behaviour. So any reasonably foreseen uses present a risk, and so should be anticipated as far as possible. Summarising what we have explored in this section, the product identification stage of the risk assessment should consider radio and non-radio functions, as well as any accessories or components that are critical for compliance. Accessories can directly influence compliance, and so specific accessories should be assessed in combination with the product, where applicable. Where accessories may be used but not provided with the product, then representative assessment should be completed to ensure accessories do not present risk of non-compliance as far as possible. Intended uses should consider what the main purpose of the product is, how it should be used, and who will use it. Foreseen uses should be considered relating to Article 3.1a, Health and Safety. Foreseen uses consider reasonably predictable behaviour and conditions. Analyse risks. At the end of this section, you will understand the difference between hazard and risk, who or what may be affected by hazards, why harms are important in risk analysis, and how to quantify risk into something that you can assess with. The second key stage for a product risk assessment is risk analysis. Risk analysis aims to clarify the hazards and risks presented by product functions already identified, who or what is at risk, and what the likelihood is. Hazard versus risk. Hazard and risk are often used interchangeably. However, despite their similarity in context, their difference in meaning is important for assessing risk. A hazard is a potential source of harm or adverse effect on a person or equipment, whereas risk is the likelihood that a person or equipment may be exposed to an adverse effect. For example, if there is a spill of water in a room, then the water would present a slipping hazard to persons passing through it. If access to that area was prevented by a physical barrier, for example, then the hazard would remain, although the risk would be reduced. Hazards. Product functions have been identified, and each function or feature of the product presents different hazards. And these hazards could be safety hazards, EMC hazards, or spectrum use hazards, for example. Hazards from product functions must relate to the essential requirements, and depending on the functions that a product supports, then the hazards may vary. But here are some examples. An example of health and safety hazard is non-ionizing radiation, or RF exposure from the radio. An example of an EMC hazard is mutual interference as a result of radiated emissions. An example of spectrum use hazard is RF output power or adjacent channel power exceeding the authorized limit for a band in which it operates, and therefore causing harmful interference to other spectrum users. Identifying the hazards covering all essential requirements is the first step for assessing any potential non-compliance. Looking at the risk assessment in reverse, the concept of applying harmonized standard for radio compliance is actually the result of identifying that the radio may not properly utilize the radio spectrum, and that the risk of this is enough to invoke the use of a test standard for proving compliant operation. With this in mind, identifying hazards for all functions and radios is the first step in the assessment process. It is important to remember that compliance begins and ends with an assessment of the risks. This has always been the case, even under the R&TTE Directive, and so although a risk assessment was not required in the technical documentation under the R&TTE Directive, the main principle of how one would show compliance conceptually the same, but perhaps was not so adequately documented as it would be under the RED. So what functions present hazards, and which essential requirements does this affect? What might cause the hazard? Who is affected? All of these are important questions to consider. If a hazard is a potential source of harm or adverse effect on a person or equipment, then we need to identify persons and equipment affected by hazards. In addition to how personal equipment may be harmed, this may vary depending on the essential requirement you're assessing. For example, health and safety, are of exposure hazard could affect the user or bystanders, and the adverse effect is that it could cause harmful physical injury or pain. For an example of an EMC hazard is mutual interference as a result of radiated emissions, which may result in the performance degradation or loss of function of other equipment that may be susceptible to such harmful interference. For example of a spectrum use hazard is adjacent channel power exceeding the authorized limit for the band in which it operates, and therefore causing harmful interference to adjacent channel users. You may notice that the hazards and the harms will vary depending on the essential requirement that you're looking at. Risk. Risk is the likelihood that a person may be harmed or suffers adverse health effects if exposed to a hazard. Equipment may be exposed to harmful effects. In the majority of cases when hazards are identified, the risks are presumed not already to be at compliant levels, and therefore this may lead to testing to reduce the risk. This means that initially risks may be conceptually high, however, risk reduction measures are taken, such as testing, so that the resultant risk is low. It is possible that even after testing, the risk is still high. This might happen when a product fails to pass a test according to a test standard, and a deviation is required. The key principle to understand is that the risk levels are determined, risk reductions are made, and the risk levels reanalyzed to ensure that the reduction is enough for demonstrating compliance. Risk levels are normally identified based on a combination of risk severity and probability. Risk severities and probabilities are determined using qualitative data or engineering judgment. A risk level matrix can often help determine the risk level. This is an example of a risk matrix, which is based on EU General Risk Assessment methodology. A reference of this methodology is provided at the end of the presentation. Risk level is estimated by a combination of probability of the event and the severity of the harmful effects to a person or equipment as a result of that event. Qualitative data can be used for a statistical approach for estimating the probability, but where it is impractical to use statistical approach, or there is no statistical data, then engineering judgments are made. And as in this example, simple terms are equated to statistical probabilities, which help realistically estimate the probability when using judgment when estimating the probability. Similarly, simple terms are also used for estimating the severity of the harm and can be related to hazards of all essential requirements. Summarizing what we have explored in this section, a hazard is a potential source of harm or adverse health effect on a person or equipment. Risk is the likelihood that a person may be harmed or suffers adverse health effects if exposed to a hazard, or that equipment may be exposed to harmful effects. Any person or product can be affected by a hazard, and the harms can be detrimental to health and safety, EMC, and radio compliance. Risks are typically analyzed using a combination of severity and probability, and the risk level is ranked either qualitatively or by judgment. Assessing risks. At the end of this section, you will understand key concepts for assessing risks, such as risk reduction techniques, applying harmonized standards and user information or warnings, Article 10 restrictions of use, and compliance statements. And so we are now at the third key stage for product risk assessment, which is in itself risk assessment. Risk assessment aims to assess the necessary measures needed to reduce the risks to compliant levels with respect to the hazards and risks identified in the previous stage. Risk assessment is divided into two main parts. One is the risk control, while the other covers statements of compliance, where the actual conclusion of the risk assessment and control measures are made. Risk is typically controlled through the use of test standards and user information or warnings. Often the strongest form of compliance demonstration is the application of harmonized standards. The R&TTE official journal lists standards that provide a presumption of conformity. These standards are agreed by the European Commission as to providing a presumption of conformity and so can be readily used for demonstrating compliance for the product functionality that falls within the scope of such standards. If no suitable or harmonized standards are available, then best practice principles and measures should be taken. R&TTE 203336 provides technical parameters necessary for demonstrating compliance with EMC and radio essential requirements. Regarding health and safety, the best fit product-specific standards should be applied. These are developed by Senelec. In some cases, such as RF exposure assessment, it may be that a safe compliance boundary is estimated. However, this is not actually adequate evidence of risk control on its own, and therefore it may be necessary to advise users to ensure a separation distance and that exceeding that distance may result in harm. And so collectively, an RF exposure assessment complete with user warning may adequately control the risk. This in essence is risk reduction. The application of standards that are not harmonized in the official journal do not provide a presumption of conformity with the essential requirements. However, the application of such standards is considered to represent a combination of harmonized knowledge and industry expertise that becomes state-of-the-art at the time of the assessment. Use of non-harmonized standards must be justified in the risk assessment because use of non-harmonized standards is a risk to compliance in itself. Where standards are subsequently listed in the official journal, these harmonized standards will be considered state-of-the-art by the European Commission and automatically invoke a reassessment of compliance. As standards are updated and new versions become available, or mandatory in the official journal, so should product risk assessment compliance strategy be updated. The result of this reassessment will likely require additional or retesting, or at the very minimum, a gap analysis would be required in order to justify that no further testing is required. This is risk control, and failing to do so could lead to a non-compliance. Some product types may have restrictions of use, which in themselves present a secondary risk and therefore must be controlled. Often risks presented by restrictions of use are controlled by advising the user or installer in the documentation. Article 10.2 and 10.10 cover restrictions of use and the measures necessary for manufacturers to control the restrictions of use. Annex 5 of the R&TTE requires an explanation of compliance with these particular articles. For example, 5 GHz RLAN indoor use bands is a restriction of use. It's a restriction that's set by the authorized use of the unlicensed spectrum. Measures should be taken by manufacturer to ensure indoor operation as far as possible in order to mitigate any risk for non-compliance. Failing to do so could potentially cause a radio non-compliance as products transit between indoor and outdoor while the radio is operating. It's important to note that mitigation limits on radio spectrum harmonization for these bands, by example, such as RF power, transmit power control, or DFS, are a condition of these bands' secondary users, RLAN, test requirements are defined by the conditions of the band harmonization, and so operating outdoors, regardless of technical compliance with, for example, EN 301893, may still present a radio compliance risk. Advising the installer or the user in the user documentation of the indoor restriction for 5 gigs RLAN is a reasonable control measure in combination with the required testing. So it's important to note that applying a test standard alone isn't always enough. Sometimes user information is also required to make sure that the product is configured or installed correctly, and therefore ensuring that the restrictions of use are maintained. The explanation of this compliance is required in the technical documentation and must specifically relate to Article 10.2 and 10.10. Compliance statement. Risk assessments are concluded with statements of compliance with the essential requirements. The result of this overall conclusion is that the product is deemed to comply with the essential requirements and therefore substantiating the declaration of conformity when it is issued. It is important to note, however, that declaration of conformity is raised once all requirements of the RED are met, not just the essential requirements. A declaration of conformity is a statement of conformity to the RED, whereas a risk assessment provides the basis for and concludes compliance with the essential requirements that then supports the declaration of conformity. And as such, a declaration of conformity is unsuitable as a form of compliance statement for the risk assessment and should not be substituted for this purpose as part of the risk assessment process. The aim of the risk assessment is to reduce risk to compliant levels. When risks are sufficiently low enough, then this implies that the product complies overall. But a statement of compliance with the essential requirements is necessary to conclude the assessment and the positive outcome of the assessment against the essential requirements. In effect, what we're trying to say is that the risks to the essential requirements of a directive were identified and reduced to compliant levels with technical basis, and therefore essential requirements are deemed to have been met. And also, where applicable, the RED Article 10 country limitations may have been studied on the Eco Frequency Information System search. And so it's necessary to complete that where there are specific restrictions of use for the radio spectrum that the product will operate within. It's important to note that the Annex 5 technical documentation requirements require an explanation of compliance with this Article 10.10 and 10.2, even when there is no applicable restrictions of use for the product. Summarising what we have explored in this section, risks can be reduced by applying harmonised standards and user informational warnings. Official journal listed harmonised standards provide a presumption of conformity. Non-harmonised standards can be used, but additional explanation of compliance supporting the use of non-harmonised standards is required. User warnings are important to advise of the risks if the product is improperly used, particularly for health and safety. The frequency information search can be used to clarify any restrictions of use of the radio spectrum regarding Article 10. Any restrictions present a risk, and so this requires consideration during the assessment. Compliance statements are required to conclude compliance with the essential requirements and Article 10. Strategy. At the end of this section, you will understand the principal considerations for document formats and content, and you will have seen a simplified example that illustrates the key elements of the risk assessment as described in the previous sections. Useful references and post-compliance considerations are also provided. What form should a risk assessment take? Manufacturers should present risk assessments in a format that is suitable to them. Reducing complexity in risk assessment is very important as not to remove the focus from showing how the product is compliant. A tabulated format supported by compliance statements may promote easier risk assessment writing and reading, However, a risk assessment can be presented in any format, including a more expanded report style. It's important to note that there is a minimum amount of information that should be expected before a risk assessment may be considered adequate. And as such, it's important that the document analysis and judgments made are properly documented. This is particularly true where non-harmonized approaches are used, where the product has restrictions of use, and whether there are any significant foreseeable uses for the equipment. Here's an oversimplified example of a risk assessment. Please note that this is not adequate on its own, but it does illustrate column by column from left to right the risk assessment process from beginning to end, covering identification, risk evaluation or analysis, risk control measures, collectively providing the risk assessment. Risk assessments can contain both types of information. However, it's uncommon for separate documents to be interleaved together, particularly where existing R&TTE directive technical documentation is being adapted for the RED. This is true where some existing approvals for a product may have a compliance strategy or evidence of compliance summary as shown at the bottom of the slide. This summarizes the essential requirements, the aspects of essential requirements of concern, and the reports, labs and standards applied for demonstrating compliance. And so a risk assessment may include both kinds of the assessment, but also summaries of compliance and what the overall compliance strategy is. In many respects, they are interleaved. And so keeping with existing documentation from any existing R&TTE approvals can be quite attractive, but it's important that the risk analysis and assessment aspects are still properly documented. It's up to the manufacturer whether they want to consolidate or whether they want to update or produce additional documentation and interleave them in a technical file. As long as the main elements of the risk assessment process are covered and the compliance statements are made, then either route should be absolutely fine. Here are some useful references. As we discussed before, the blue guide is the official interpretation for the EU legislation. The red guide provides additional information relating to the RED. It has no legal standing, but it may expand on some of the aspects of the RED that the blue guide cannot. Some aspects of the risk assessment methodology, for example, risk level determination based on probability and severity, can be found in EU general risk assessment methodology. The full reference is provided there. In addition, ADCO presentation on performing a risk assessment on a practical example is another good source of information on a practical example for a risk assessment of the RED. Both of these are publicly available, so you may want to explore these for more information. It's important to remember that a risk assessment is in itself not evidence of compliance. However, it is intended to be used as part of a compliance strategy for demonstrating compliance with the essential requirements. Where equipment is capable of taking different configurations or operating with modes or parameters outside the scope of what has been identified in the original risk assessment, then these differences will also require further assessment. Any modifications to a product after self-declaration or certification automatically present a risk of non-compliance with the essential requirements, and therefore a reassessment is invoked for each change, regardless of whether those changes appear to be inherently benign as far as risk to the essential requirements. Even when a modification may appear to be benign for compliance, this does not change the fact that an evaluation or decision is made to conclude that there is no risk presented for the modification. And so reassessing risk after changes is very important, and documenting those judgments with those changes is equally important. Risk assessment and management is an ongoing process. Much like routine vehicle checking, reassessing compliance should be maintained periodically to ensure compliance solution is fit for purpose. That, in essence, is risk management.
If you have any questions regarding the webinar topic or what we do, feel free to email us at telecoms@tuvsud.com. Thank you for your time and have a good rest of the day ahead.